Hello there, Mr. Sutton here. I've got the IM3 Honors 4-8 Extra Practice number 2 solutions here for you, dealing with max and min. For this problem, we have a 500-foot roll of fencing in a large field. We're constructing a rectangular playground. We want the dimensions of the largest such playground and that area. So let's draw a rectangle, because that's what we have to work with. And let me express each of these sides in terms of x, so that I can start building a function to represent the area of this thing. So let me start by making this side here x, and this other side across from it must then also be x, because it's a rectangle. They're the same length. These other two sides are a little trickier. So the key here is I've used up 2x feet of fencing already. That means I have 500 minus 2x left over for these other two sides. Well, if there's 500 minus 2x left over for both of these and I have to split it evenly, dividing 500 minus 2x by 2 gives me 250 minus 1x. So I have 250 minus x for this side, and then the same thing for this other side. All right, so the area in general of a rectangle is length times width. The length in this case we can call 250 minus x, and then our width we can call x. So now this is a quadratic, if you multiply this out, that I have to find the maximum value of. Now we know with quadratics, parabolas, the max value happens at the vertex. So we need to find the vertex. And since this is intercept form, I can find the vertex by just averaging the zeros together. So the 0 for this first factor is just going to be 250, because 250 minus 250 is 0. And then the other 0 for this other factor of x is just going to be 0. All right, so if I average these together, that is going to give me the x value of the vertex for this function. It's also going to give me the width of this rectangle. So I'm going to say width equals x value of the vertex equals 250 plus 0 over 2. Again, basically averaging the zeros together. Basically 250 over 2, that's going to be 125. That's going to be in units of feet for this problem. Now to find the length, because we also need that to know the area, the length is going to be 250 minus 125, which is going to be also 125 feet. So this ends up being a square that maximizes the area. And then the actual area is going to be our length of 125 times our width of 125, which I will do on the calculator now. So we have 125 times 125, or 125 squared you could have done. And that is 15,625, and that's in units of square feet. For this problem, we have a formula for the height of a rocket, this h function here, and this is a function of time, t. We want to find the number of seconds to reach the max height and what that height is. So if we're trying to maximize a parabola, we need to find the vertex. To find the input value of the vertex, since this is just standard form, I can say the t value of the vertex is going to be negative b over 2a. That's my vertex formula for standard form. So this is going to be negative 96 over 2 times the a value here of negative 16. So that's negative 96 over negative 32, which is actually exactly 3. So that's kind of nice. 3 seconds is our units here. And now to find the number of feet for our max height, we just have to plug this 3 back into the h function, and that basically gives us the output value of the vertex, which we know on a parabola is going to be the highest value, at least if it's an upside down parabola like this one is. So we plug 3 in for t in the h function, and let me see what that comes out to on the calculator. So crunching all those numbers on the calculator, I end up with 194, and that is units of feet. On this problem, we have the temperature of a school given by this function, where T is in degrees Fahrenheit and H is the number of hours. We want to know the hottest time of day and the temperature at that time. So we're trying to maximize a quadratic function in vertex form, parabola vertex form, and we know that the max and min always happen at the vertex. So let's write down the vertex first. So that's going to be 4.5, whatever's being subtracted from the input inside this squared parentheses, that's the input value of our vertex. So 4.5, comma, 76, whatever's being added out here outside the squared parentheses, that's the output value of our vertex, the y value. So now the hottest time of day is going to be this input value of 4.5, so that's 4.5 hours. And the actual temperature is going to be the output value of the vertex, which is 76 degrees Fahrenheit. On this problem, the likelihood of getting sunburned, B, as a percentage is given by this B function, which is a function of T, time. And time is number of hours after noon. So that'll be important when we're trying to figure out at what time we have the least chance of getting sunburned, and also what that chance is. So we're essentially, if we're trying to find the least chance of getting sunburned, we're trying to find the smallest value of B in this function, which is to say we're trying to find the minimum value of a quadratic function. Since we're trying to find the smallest value of a parabola, we need to look at the vertex and see what the output value is there, which means I need to find the vertex in the first place. Now, the good news is that this is already in vertex form, so I can pick the vertex right out of here and then just get what I need out of that information. So the input value, the t value of the vertex, is whatever I'm subtracting from t inside this squared parentheses. Well, I'm not subtracting anything, right? I'm adding 10, but that really means I'm subtracting negative 10. So I have a vertex with negative 10 as the input. Now the output value of the vertex, the y value if you will, or the b value on this problem, is whatever you're adding outside the squared parentheses. So that's going to be a positive 15 here. Okay, so we have negative 10 as the input value. That's telling us the time at which we have the least chance of getting sunburned. So we have a time of negative 10 hours, but since so if we have negative 10 hours, that basically means since t represents hours after noon, this is saying 10 hours before noon is our least chance of getting sunburned. So that's going to end up being, let's see here, 12 minus 10 would give us 2 a.m. So if you want to go out on the beach at 2 in the morning, I guess, you have very little chance of getting sunburned. And the actual chance of getting sunburned is going to be the output of the vertex, this 15. So that's a 15% chance of getting sunburned. For this problem, a biologist's formula for predicting the number of impulses fired after a nerve is stimulated is given by this I function right here, where I is the number of impulses, x milliseconds after stimulation. We want to find the maximum possible number of impulses. Okay, so we need to find the time at which that happens and then plug that into this function. Since we're trying to basically maximize a quadratic function, we need to find the vertex. And since this is standard form of a quadratic, we can use negative b over 2a to find the x value of the vertex. So that's going to be negative 40 over 2 times the a value, negative 1. Since that's negative 40 over negative 2, that's going to be 20, and x is in units of milliseconds. So how many impulses do we get at 20 milliseconds? So just plug 20 back into the I function right here. That'll give you basically the I value of the vertex. And what's that going to come out to? Let me do this on the calculator, might as well. So plugging all that in and letting the calculator handle PEMDAS, we end up with 355, and that is impulses.